So in this course, we'll be using two primary unit systems. We'll be using the SI system and we'll be using the USCS system. Okay. For both of these systems, these are the base units for length, time, mass, and force, which are the only quantities that we will be interested in this class. So the one thing I do want to mention that's not listed on this next page is that we just talked about how weight is equal to the mass of an object times g. G is equal to, for the SI system, g is equal to 9.81 meters per second squared, and then for the USCS system, it's equal to 32.2 feet per second squared. Okay. So if we go to the next page, sometimes you may be asked to convert between the two primary systems, between USCS and SI. So the most common things are going to be force, distance, and mass that you would have to convert between the two. So sometimes it's useful to just be able to convert these numbers in your head, or at least give yourself an approximation in your head. So a force. So one way to remember the conversion between pounds and newtons is that 1 pound is equal to 4.45 approximately newtons. One way you can get an approximation is that a quarter-pound hamburger is approximately 1 newton. Not great, not perfect conversion, but in your head, if you need to convert between pounds and newtons, 1 pound is approximately 4 newtons, or a quarter-pound hamburger is approximately 1 newton. Distance between two things, or converting between feet and meters, you can remember 1 foot is equal to 0.3048 meters. The one I always remember is that 1 inch, which is a 1/12 of a foot, is equal to 25.4 millimeters. Right. And then so the mass unit for USCS is a slug, which is about 14.59 kilograms. Typically, what I would do is, if I had a mass in slugs, I would convert it to a weight in pounds, which is a force. Then I would convert that weight to a weight in newtons, and then I convert that weight back to a mass in kilograms. I think that's a little bit easier sometimes than remembering 14.59. Alright. So when you're using the SI system, but also for the English system, it's important that you are familiar with the following SI prefixes. So there would be the nano, a giga, a kilo, a milli, omega, tera, pico, and micro. These are the most commonly used symbols used. So it'd be useful for you to know the differences between them. So you need to know what is the symbol that goes in front of it and the power, or the power to the 10th that it goes to. Okay. So for example, I'll do 1 just to get it kind of started. So if you look at a milli, so for example a millimeter, you would use the symbol lowercase m, and it would be the same as 10 to the minus 3. Okay. So I'm going to give you guys a chance to try to fill out this table on your own. So take a second and fill this out, and then when I restart the video, all the symbols will be filled out. Okay, so now we're back. As you can see, all of the symbols and powers have been filled. The only thing I want to clarify here is it looks like this is supposed to be the Greek letter mu, not an M. So for micro. Alright, so when you're using prefixes, you should try to use the closest prefix. We will not use any metric system prefixes, so don't use the word don't use the prefix centis or deca. If you see a unit with an exponent, that refers to both the unit and the prefix. So let's say you had an area of 100 millimeters squared. That's equivalent to 10 millimeters times 10 millimeters. The next thing is that you should typically want to convert all your units to base units before beginning calculations. So what that would mean is if you had 100 millimeters before you start calculations, it's useful to then to simplify it down to 0.10 meters. Okay, so try to convert everything back down to the base units. Okay, so the base units for length is meters, the base units for mass is kilograms, and then the base unit for force is newtons. Okay, so try to convert back to the base units before you do your calculations. So the other unit thing to keep in mind is typically keep everything in terms of the base units in the denominator. So if you had newtons per millimeter, convert that to kilonewtons per meter, and then typically you would separate things with a dot. Okay, so you separate kilograms and meters with a small dot symbol. Alright. So that concludes this video on the unit systems we'll be using in this course.